Hi folks, this is Tom. Today I'm going to show you how to do a quieting check on a communications receiver. This is the AOR AR-5000 receiver. This is an absolutely iconic one here. This is one of your DC to daylight receivers. It covers 10 kilocycles to 2.6 megahertz. This one here is especially cool because it's unblocked in the cellular range, so it'll tune right straight through the cellular range. Okay, so what a quieting check is a quick check. It basically tells you when the receiver starts receiving useful information. You can break a squelch like on FM or possibly AM as well. That may or may not tell you something. But when you can actually put a signal into a receiver and tell when it's actually being demodulated, when it's being processed enough so you can actually hear it, that's important. So basically what a quieting check is we're going to take the signal generator here. We're going to generate a 1,000 cycle tone. Right now it's in the FM mode. And what we can do is also turn the FM mode off. And what we can do is we can put an AM mode in here. And typically in AM, what you do is you measure quieting at 30% modulation with a 1,000 cycle tone. We can go either a 400 cycle tone or 1,000, but we're going to do 1,000 on here. And we're going to go through. We're going to do this with AM, we're going to do it with FM, and we're going to do it with upper and lower sideband, and we do it with CW as well. For the two sidebands and CW, we're going to use an unmodulated carrier, but for AM and FM, to get a 1,000 cycle tone, we actually have to generate a 1,000 cycle tone. Whereas on upper lower sideband and CW, what we can do is we can dial the signal generator slightly off of the receive frequency, and that'll automatically generate essentially a 1,000 cycle difference. Okay, obviously the lower that you can hear something, the better the receiver is going to be. The figure that's usually used is 12 dB or 10 dB quieting. We're going to use 12 dB. That's a little bit more strict than 10 dB is, but we'll see how this receiver does. Here goes. So we're here at 28.4. Let's put this guy here on AM. We're going to do AM first. CW, I think there's AM right there. Okay, we're going to break the squelch here. Turn up the volume. You can just barely hear something here. And what we want to do is bring this up to the 12 level. So what this is doing now is this is generating a 1,000 cycle tone. And what the SINAD meter is, signal and noise added together, what it's doing is it's looking to see how much 1,000 cycle tone there is and noise, and comparing that against a pure 1,000 cycle tone internally. And that's what gives us our SINAD there. So there's a couple of things going on. Okay, let's see. We're going to go here, amplitude step, increment 0.1 microvolts. Now we can step this 0.1 microvolt at a time. Turn the volume up. You don't need a whole heck of a lot of volume. See right there? If we turn this down here, it's starting to change now because there's no noise, so it thinks it's quieting. But right there, and let's start turning this up. Yep. There we go. We've gone a little bit higher. So now that we're at 1.5 microvolts there for AM, 6 kilohertz wide. So let's go amplitude increment set, 0.01 microvolt. And now what we're going to do is we're going to drop this slightly. So we drop it exactly on the 12 mark. And it's going up and down a little bit. And right there, about there, looks like it's averaging pretty close, and we're at 1.4 microvolts. So let's go AM, 1.40 microvolts for 12 dB quieting. That's not bad, actually. Okay, let's go to FM for the fun of it here, since we're here anyways. Let's see, FM. We're going to go up here, back one. And what I've been typically doing is changing the bandwidth for FM to 15 kilohertz. There we go. Down here, we can probably get away with 6, and it'll be better quieting. Now, what we'll do is we'll go up, and you see it's going to take probably a lot more. Let me double. Oh, it might help if we actually use FM instead of AM. AM, tout fini, goes away. And again, the criteria here is 1,000 cycle tone at 3 kc's deviation. And oh, there we go. This is really good. In fact, what we're going to do is we're going to go back here, amplitude increment set, 0.1 microvolt, and we're going to drop it way down. Let's see where it starts coming out here. Right there, we're down to 0.3, amplitude increment set, 0.01 microvolts, and let's get it to 12. That's about there, 0.37 microvolts. 0.37 microvolts, and that's at 15 kc's bandwidth. Let's see what happens if we drop the bandwidth. Function, bandwidth, drop it down to 6. Oh, Enter. And that's definitely gotten better. Let's drop it down and see where it goes. Yeah, it's about right about there. By changing the bandwidth from 15 kilocycles to 6 kilocycles, we're now 12 dB bandwidth, or dBq here at 0.30. That's pretty good. Let's see what happens now when we go to single sideband. Let's turn the FM off. AM is off. That's good. We're right there at 28.4. And what I'm going to do is I'm going to change the tuning increment. But it's pretty quick. What we're going to have to do is we're going to have to go all the way down here. So that's megahertz, hundreds, tens, single kilocycles, hundreds of cycles, tens of cycles. So this will be 10 cycles per tuning step now. And we can go up and we can go down. Okay, here goes. Let's change the bandwidth here. Function, bandwidth, 3 kc's. And let's go to upper sideband for the fun of it here. So that's typically what you're going to use above 10 megahertz. So we got a bunch of noise there. And let's see what happens as we tune this guy up a little bit. Oh, hear that. There we go. I've got it centered right now. It looks like we're almost 1,000 cycles high, not quite. And we're about 14 dBm, or 14 dB quieting. Now we're dropping this here, and now we're right about 12 or so. And look at that, we're at 0.24. So at upper sideband, 0.24 microvolts, and that's at 3 kc bandwidth. Let's go to lower sideband real quick. Let's see, mode, LSB, and now what we got to do is we got to go to the other side of this. So that's high, so this one's going to go low. There we go. That's right about there, and it's just slightly low. Literally, I punched it up a couple of notches and down one there. So it looks like we're at 0.25. So those filters are tracking pretty close. And let's go to CW next. Okay, let's see. Mode. Here's CW. Enter that, 3 kc still. Oh, look at that. And 0.22 microvolts for 12 dB quieting. So that's pretty cool. So if you look here, AM seems to have the biggest band, well, almost the biggest band. FM is the biggest bandwidth, but AM, 1.4 microvolts to give you 12 dB. And then you've got FM, wideband FM at 15 kcs is 0.37. If you go down to 0.6 kcs, it's 0.30. Upper and lower sideband are side by side here at 0.24 and 0.25, so they're almost the same. And CW comes even better at 3/100ths of a microvolt better, or 0.22 microvolts. That's phenomenal. So, that's that, folks. Appreciate you watching. Thank you.